So no matter what prisoner 2 chooses to do, prisoner 1 is always better off choosing to turn himself in and confess to the authorities. That means that prisoner 1 has what's known as a dominant strategy. A dominant strategy occurs when you have one best choice regardless of what your partner chooses to do. Prisoner 1 should always confess, no matter what prisoner 2 chooses to do. If prisoner 2 chooses to confess, prisoner 1 should confess in order to get 3 years in prison rather than 20. If prisoner 2 decides not to confess, prisoner 1 should still confess because 0 years in prison is better than 1. He will always choose to confess. We could do the same thing looking at it from the perspective of prisoner 2. What should he do? And it turns out that he also should always confess, should always turn himself in. Because both sides have a dominant strategy, because they will always confess because it's best for them, we have what's known as a Nash equilibrium. A Nash equilibrium exists when neither party has an incentive to change their behavior independently. Would they rather avoid going to jail for 3 years? Of course. 1 year in jail for both of them is better than 3. But neither one of them has an incentive to change their behavior on their own. If prisoner 2 chooses to change his behavior and not confess, then he goes from 3 years in prison to 20. There's no reason for him to do that. Same with prisoner 1. If he chooses not to confess, then he'll go from 3 years in prison to 20. There's no reason for him to do that. So these two players are in a Nash equilibrium in which they both choose to turn themselves in. It's not optimal. It's not the best. 1 year in prison is better than 3. But that's where they'll end up because they're each following what's in their own individual best interests. Here's another example. What should Coke do if Pepsi chooses to advertise? They've got options here. Again, this first number relates to Pepsi. The second number will relate to Coke. If Pepsi chooses to advertise, then Coke's got choices. They can either choose to advertise and get 80 or not advertise and get 45. So Coke should definitely advertise because 80 is better than 45. What should Coke do if Pepsi chooses not to advertise? Well, they've got a choice. They can either advertise and get 120 or they can not advertise and get 100. So what's best for Coke? If Pepsi chooses not to advertise, then Coke should advertise. In both cases, Coca-Cola is going to choose to advertise their product. That is their dominant strategy. No matter what Pepsi does, it's always in Coke's best interest to advertise. And because this game is known as a symmetrical game, because the payouts are the same for Pepsi as they are for Coke, Pepsi will also advertise. So this again leads us to an option or an outcome where they each get 80, but that's not as good as if they both got 100. They'd like to get here, but neither one has an incentive to change their behavior. If Coke stops advertising, they lose money. If Pepsi stops advertising, they lose money. So this is the Nash equilibrium. Not the optimal one necessarily, but the one that they will land on when making decisions in their own best interest. So how do firms learn how to work together? Well, they could use formal agreements, but as we said, in America at the very least, those formal agreements, those cartels, are illegal. So that's not really an option. Instead, they're going to have to use what's known as tacit collusion. That is, we're going to develop an understanding about how to behave without having a formal agreement. In order for this to work, we're going to have to play this game multiple times. The prisoner's dilemma, the problem with that is you get one shot at this. You either confess or you don't confess. You either go into jail or you're not. There is no chance to play this game tomorrow. But if we're constantly playing this game over and over again, every single day, trying to make a decision about how to operate my business, and you're trying to make the same decisions every single day, then we can follow a game known as tit for tat. And that strategy will help us learn how to work together. In tit for tat, what we'll do is treat our partner the same way they treated us in the previous round. So if we go back to the Pepsi and Coke example for a minute, if we assume that these two companies We're going to play this round of advertise and don't advertise. We're going to play this game round after round after round. Then from the beginning, we can presume that we're going to work together. I mean, the idea is to work as monopolists in order to maximize our profits. So let's begin with the presumption that we're going to work together, in which case we're not advertising. If, let's say, Coke chooses to cheat and advertise, they'll move from a place where the combined profit is 100 and 100 together is 200 for the entire industry. We're going to move to a place here where Coke increased their profit at the expense of Pepsi. Now, the next day, we're going to play this decision, advertise or not advertise again. Pepsi could continue to not advertise, but at their own detriment. And they're not dumb. They're not going to continue to hurt themselves or allow themselves to be hurt. So next round, Pepsi is going to choose to advertise to get back at Coke. Coke has a choice. They can continue to advertise, in which case we find ourselves in this situation of 80 and 80, which is less than what we had when we cooperated. Or they can choose to let Pepsi advertise, and they can stop advertising, in which case they get themselves punished. But the benefit of that is they are now no longer any better or worse off than their partner Pepsi is. So in the next round, they can both just agree to let it go, stop advertising, and we go back to this sort of collusive outcome. Tit for tat basically says, if you hurt me, I'll hurt you back, knowing that you're going to get hurt back if you choose to cheat, and knowing that long-term cheating is less advantageous and leads to less profit than if we were to work together. Firms will, over the long term, learn how to just cooperate with each other. Anytime they slip and cheat, the next time around, they get cheated right back. Everyone's made whole, and we go back to cooperation. So as long as firms can implement tit for tat by playing over multiple rounds, we will begin to see sort of a tendency toward collusive behavior. It's tacit, it's not required, but it's understood that this is how you should behave. It's understood what will happen if you get out of line, and as a result, you do see more cooperation. Not every game is symmetrical. So you do need to understand that not every game has a dominant strategy for both players. For example, we look here and see we got Pam and Margaret. Do both players have a dominant strategy? In the case of Margaret, the answer is yes. She does have a dominant strategy. If Pam chooses to charge a high price, then Margaret has a choice of either charging high or low, either getting 80 or 100. 100 is better than 80, so she'll price low. If Pam chooses to price low, Margaret has a choice of charging a high price at $50 or a low price and earn 60. 60 is better than 50. So no matter what Pam does, Margaret will always choose to price low. That's her dominant strategy. Regardless of what Pam does, this is what's best for Margaret. Does Pam have a dominant strategy? Well, if Margaret chooses to price high, then Pam has a choice. She can either go high for 80 or low for 75. 80 is better than 75, so Pam will go high. If Margaret goes low, she can go high for 20 or low for 60. 60 is better than 20. So Pam would go low if Margaret goes low, but she'll go high if Margaret goes high. Pam lacks a dominant strategy. There is no one best choice regardless of what her opponent or partner chooses to do. Her decision is dependent on what Margaret chooses. So Margaret has a dominant strategy of pricing low. Knowing that Margaret will always charge low, Pam will choose to also go low because 60 is better than 20. So they will find themselves in this situation of both pricing low. This is still a Nash equilibrium. There's no incentive for either one to change their behavior independent of the other. Pam's not going to go high. That's going to cost her money. Margaret's not going to go high. That costs her money. So they're both going to end up at Nash equilibrium. Nash equilibrium will always occur whenever at least one of the two partners has a dominant strategy. One final thing to keep in mind. Your decision is based entirely on what you receive. It doesn't matter what your opponent gets. Your decision might lead to your opponent earning more money than you. It doesn't matter. As long as you're earning more than you could have doing a different decision, you're good with it. It doesn't matter what the other side's payouts are. You only make decisions based on what gets you the biggest payout possible. I would encourage you to do some practice on the problem sets with this, because game theory can be a little tricky learning how to read the matrix. And next time we'll talk a little bit more about how companies choose to differentiate their products, and I will talk to you then.